Today in topic 11, we're going to be using coordinate geometry to determine which quadrilateral we have. So the first question is, what is coordinate geometry? Well, it's when we have a grid and we're using the distance, midpoint, or slope formula. So let's look at these. The distance formula, I'm going to determine what the length of each side is. So it comes in handy for those congruent sides. Midpoint formula is used to determine if two things bisect each other. And finally, slope is used to determine if two segments are parallel or perpendicular. So let's look at our quadrilaterals and figure out what we're actually dealing with and what we need to use. So in my handy chart, I wrote down all the quadrilaterals we've talked about. Now, for a parallelogram, here are the 5 properties we learned. If opposite sides are parallel, I'm going to determine if opposite sides have the same slope. Opposite angles are congruent. I can't really do anything with coordinate geometry for that, so I don't really worry about that property. Now, opposite sides are congruent. I'm going to check both sets of opposite sides and see, using the distance formula, if they're the same length. Diagonals bisect each other. I'm going to find the midpoint of both diagonals and see if it's the same midpoint, because then they bisect each other. One set of opposite sides is both parallel and congruent. So this time I only have to check one side, and I'm going to see if it has the same slope and use the distance formula to find out if it happens to be the same length. So if any of those things hold true, I have a parallelogram. So next, if I'm going to deal with my rectangle where all the angles are 90, I can check consecutive sides and see if they have opposite reciprocal slopes, because that's what makes them perpendicular. Diagonals are congruent. I can check the length of both diagonals using the distance formula and see if they happen to be equal. Now, if I want to see if something's a rhombus, I can check the length of all 4 sides using the distance formula and see if they're the same. Diagonals bisect opposite angles. I can't really do anything with that. That's kind of like seeing how big angles are. And then finally, diagonals are perpendicular. I'm going to check for opposite reciprocal slopes. Now, if I want to prove that something's a square, I have to prove, first of all, that it's a parallelogram, it's a rectangle, and it's a rhombus. So once I know it's all 3, then it happens to be a square, but there's no special property for that. Now, a trapezoid. Opposite sides are parallel. So I need to check one set of opposite sides. I could probably check the other one to make sure that it's not a parallelogram, but I'm looking for the same slope. 2 pairs of consecutive angles are supplementary. Can't really do anything with that. Now, in order for it to be an isosceles trapezoid, those non-parallel sides have to be congruent. So I'm going to check the non-parallel sides using the distance formula and see if they're the same. Or I can check if diagonals are congruent, also using the distance formula. Both pairs of base angles are congruent. Once again, I'm not going to be able to prove that angles are congruent. Now for a kite, 2 pairs of consecutive sides are congruent. I'm going to use the distance formula and see which ones are congruent. Diagonals are perpendicular. I'm going to use slope, and I want to see if they're opposite reciprocals of each other. Exactly 1 pair of opposite angles are congruent. Can't do anything with that. So now that I know what I need to do to see things are congruent, let's see if we can come up with some of these things ourselves. So if I look at this, step one is going to be to plot these points. So let me go ahead and plot them. -2, 3 is right here, and that's point A. B is at point -2, 1. And then C is at point 1, 2, 3, -1, 2, 3. And let's see what we're trying to make. I'm trying to make an isosceles trapezoid. So I really kind of want to look at what that things look like. And I, of course, can't draw to save my life on this. It kind of looks like this. These sides are parallel and these sides are congruent. So this one here, and I have this side here. I'm horribly going to draw this one. Okay, now I want to find the slope of this line. I'm going to change my color in case I draw. 1, 2, 3, 4. 1, 2, 3, 4, 5. So the slope of BC is -4/5. Now if I go from A, -1, 2, 3, 4, 1, 2, 3, 4, 5. I'm looking at this. And it's going to be somewhere along this line. If I can draw it straight. Now, I need these two sides to be the same. This one is 2, so this one is going to be 2. And so this would have to be point D, which is at 1, 2, 3, 4, 5. -1, 2, 3.